Okay, you're going to be using a Lincoln Electric Power MIG 350 multi-process. The multi-process meaning they will do MIG, TIG, stick, flux core, pretty much everything except for TIG welding aluminum. These machines have a ton of settings. They're a little bit intimidating at first, but you have an owner's manual that I printed off for each of you. Feel free to explore that manual and try some of these settings. On the inside of the cover where your wire is held, this is a top feed system, so the wire is coming off of the top of the roll. Pretty important to keep it from jamming up. We're using a push-pull gun, so you'll see the connection there for either a spool gun or a push-pull gun, and the switch to make sure that you are in the push-pull mode for this particular gun. With that push-pull gun, you're having a two sets of drive rolls. One is in the gun itself, which is the master system, and the typical feeder rolls on the machine are the slave. The slave system is going to be very, very loose. In fact, I have hardly any pressure on that. All this is for is to help get some tension off of the roll itself, but the rolls inside the gun are the ones that are actually feeding it through. This is 035 4043 aluminum, so it's pretty soft, and it can be a little bit finicky when you're feeding that system. With these we use special drive rolls. The drive rolls are very, very smooth compared to typical drive rolls for hardwire, carbon steel, or stainless steel MIG. So they're very smooth. The guides themselves are Teflon, or very hard plastic type material, to keep them from having any metal to metal contact other than what little bit it gets on the rolls itself. The liner that runs through the gun is also a Teflon liner, so we have some specialized equipment for it. On the push-pull gun itself, again, you have a drive roll system that's inside the gun, which does make the gun a little bulkier, not near as bulky as a spool gun. You can relieve pressure by pushing this little knob. That is, if you are feeding a new roll wire and you need to initially get it through the neck of the gun, you can relieve some of the pressure off of it to allow it to feed a little bit easier without jamming up. There isn't very many adjustments that you really need to make inside of this itself. Just every once in a while open it up and make sure there's not a ton of aluminum dust in there. It may need to be cleaned out from time to time. The tips themselves are actually designed for aluminum, so even though this is an 035 diameter wire, we're not using an 035 tip, or we're not using the same 035 tip that would be used for carbon steel MIG. The bore, the hole inside the tip, is actually a little bit more polished than for a carbon steel, so that it has good contact and there's no grooves for the soft aluminum to catch on. It's also a little bit oversized. So an 035 tip for carbon steel is going to be just a few thousandths of an inch over 035. This one's going to have more of a wider tolerance on it. This needs to be a little bit bigger since aluminum expands a lot when it's hot. So if you use a regular carbon steel welding tip, contact tip on this, is probably going to give you a lot more bird's nest and jam up a lot more, just because it's not quite big enough for that aluminum wire. The entire head of this comes off. In fact, when you're welding, you can spin it around any angle that you want, which is pretty convenient. But when you're feeding a new roll of wire through it, it's helpful to get this head off of it so that it feeds through a little bit easier without jamming up. Again, the torch neck itself is going to have a Teflon liner in it as well. This is made to come off, but when you're putting it back on, you need to be a little bit careful, in that it tends to want to jam up, and you have to make sure it seats all the way. And when you have it in your hands, you can actually feel it kind of click in when it's sitting all the way in there. And when I had that gun out, there was a bunch of O-rings that are sealing your gas. So if this isn't pushed all the way in when it's tightened, you're going to get some problems with contamination, since it's got a little bit of gas flow problem, since the O-rings are not lining up correctly with it. Alright, let's look at some of the settings on this machine itself. Alright, we're going to look at our machine settings here for a little bit. When you first look at the front of this machine, it can be a little bit intimidating with all the items that we can change. Some of them are more beneficial than others. This is a stick MIG and TIG machine, so some of these settings are a little more useful for other welding processes, not necessarily MIG. On the left hand side, I've got all the features that I can either turn on, turn off, or I can set for different fine-tuning methods. The first thing that I'm looking at is the weld mode, and the chart here gives me the recommended weld mode setting for the type of welding I'm doing, the shielding gas I'm using, and the wire diameter that I'm using. These are just pre-programmed electrical characteristics. So with the weld mode 5 that I'm in, 5 and 6 are actually just constant voltage MIG settings, and this is what you're familiar with the hardwire first semester MIG and the flux core. These are just straight what we call non-synergic types of welding, and non-synergic just basically means my volts is not connected to my wire feed, so I can change these independently. And you can see I can turn my volts up and down, I can turn my wire speed up and down, and neither one affects the other, and that's basically what synergic and non-synergic mean. This is fine for a lot of settings that we do with hardwire and flux core. With aluminum, it's a little bit more finicky of a metal, so we've got some special features with it. We are using 4043 aluminum, and we've got 3 options. We've got just GMAW, which is by default spray arc. We've got GMAWP, which is pulse, and we got GMAW pulse on pulse. So we'll look at all of them, but for now I'm just going to take us to the regular old spray arc. We're using 035, and we're going to want weld mode 148. Now when I go to 148, you're going to see the display flash a little bit, and so we're still reading volts and we're reading wire feed speed, but now we are in a synergic welding process mode. So I'm going to change the wire feed on my gun, and as I decrease the wire feed, you can see the voltage decreases to match it. Now this is beneficial. If I get the settings that I really like, then I can turn it down a little bit, turn it up a little bit, and still not change the electrical characteristics of the puddle. The wire feed speed is going to change my volts, but I can still change my volts independently. So what you do initially is you get the machine set where you want it, and say I wanted 23.5 and 400 wire speed. Then when I change my wire feed, it's going to change my voltage to give me the same characteristics as what I originally set it at. And what's nice about that is when you guys are welding on this cold aluminum, when you just set up a new T-joint, that first root pass is going to run in there cold. Aluminum sucks the heat away from it pretty quickly. So this allows me to change my settings and have a little bit hotter of a root pass, and then I can use my wire feed to back the wire feed down, which will change my voltage to match and give me the same weld characteristics. So this is something that I imagine that you guys will be doing, is adjusting your wire feed to match the voltage. So again, that's weld mode 148. With weld mode 149, that takes me into pulse, and now if you notice, it looks like I got 1 volt, but we're not reading volts anymore, we're reading trim, and trim is basically arc length. So the default setting is 1.00, and that is going to be what Lincoln has determined is the perfect arc length for a given wire feed speed. So on this, I can change my wire feed speed, but I never see my voltage. Voltage is going to be determined by what my arc length is set at. So I can go down, and when I go down under 1.0, it's going to decrease my arc length. My arc length is going to get smaller. Usually when the arc length is getting smaller, that means that the overall voltage is going to drop. Voltage is pressure. It doesn't take as much pressure to jump a little gap, so the voltage is going to drop. My weld is going to be a little bit cooler overall. If I go above 1, you're going to see the arc length increase, and as the arc length increases, again, voltage is pressure, so I need a little bit more pressure to jump a bigger gap, so the machine is going to increase the voltage to match what my desired arc length is. Again, this is something that you're going to have to play with and figure out what you like when you get into these settings. you can physically see it change the arc length. If you just do 1.02, you probably won't notice. But if you go to some extremes, you'll be able to see the arc length get longer and longer or shorter and shorter. I recommend starting at 1 and working from there. You'll be able to fine-tune and figure out exactly what you want with that setting. In your welding procedure for this course, I have 0.8 to 1.2, I think, as the ranges for it. So our weld mode 149 again is our pulse. Now what pulse is doing is, instead of having just a straight spray arc where the wire or the molten metal is coming off the wire in tiny little droplets happening about 200 times a second, with pulse I have a high peak current and I have a lower background current, and at a given frequency, whatever the machine determines it should be, it's going to pulse between the high and the low machine settings. And what that's going to do is allow metal to be transferred across the arc only when I'm at the peak current. When I'm in the background current, it's going to be enough to keep the arc established, but no metal is going to be transferred across the arc. So again, it's like the weld is getting hot and cold, hot and cold, hot and cold. The advantage to this is that thin material, we still, with aluminum, we need some heat to get some penetration, but thin material is going to heat up quick, so it allows less heat to be put into the metal but still be able to achieve the spray characteristics. I need at least 90 amps and an argon-rich gas in order to have a spray arc with 035 aluminum wire. So this technically allows me to run under 90 amps as an overall current. Since it's not staying at one setting, it's getting hot and cold, hot and cold, hot and cold. It'll jump up above 90 amps to spray, and then it'll drop down below it to give me my background current. It's a nice way to be able to control our settings on thinner material. Now you guys are welding on 1/4 inch thick plate, but you have relatively small T-joints. So when you get a couple passes in there, you know it already starts to get hot. So out of position welding, overhead, vertical, pulse could be helpful in controlling the heat, even though you're on a little bit heavier material. Pulse is generally designed for 1/8 inch or under, but it can be beneficial on this thicker stuff when you're running multi-passes and the plate's getting pretty hot. It's again our regular pulse setting. When I go to pulse on pulse, which is setting 98, it's still a pulse process, so you're still seeing trim as my setting. I'm just setting arc length and wire feed, and the machine's setting everything else for me. But what's neat about pulse on pulse, and this was designed especially for MIG welding aluminum, is unlike pulse, where I have just one high and one low, and it's repeating that process about 200 times a second. What pulse on pulse allows me to do is the machine will determine how many peak currents I should have, and that'll be followed by the same amount of background currents. So at whatever given setting, I may have 2 highs and then 2 lows, 2 highs, 2 lows. The advantage to that again is thinner material. It's going to allow it to cool down when I'm in the background current, and the weld's not going to blow through or fall out on me. It also allows me to have basically a TIG weld appearance where I have very distinct ripples. Again, you're only depositing metal when you're on the peak current, so your travel speed will stay constant, but you're getting hot, cold, hot, cold, hot, cold, and everywhere where your hot is where a ripple is going to be formed, because metal is being deposited. When the current goes to background, no metal is being transferred, you're still moving. So when the next droplet of metal comes, it's going to be a little bit farther away from the first one. So you get these very distinct ripples with it. And that is a pretty neat process designed, again, especially for MIG welding aluminum, and in particular thin material. So when you get into that barrel of 14 gauge aluminum, pulse on pulse may be where you want to go to be able to weld some particularly thin material. The last setting that I'll show you on this that's related to aluminum is this one here, power 40. Power mode 40 initially looks pretty similar to a pulse. I don't technically have a trim. Now this is not voltage, it's not trim, this is kind of a little bit weird. What power mode 40 does is a very high speed electrical adapting. So when I'm actually welding, the machine is sensing the current that's flowing through my wire. It's sensing the resistance of that wire, the resistance of the arc, how fluid the puddle is. It's sensing a whole lot of different things, and it's adjusting your wire feed, your voltage, your amperage. It's doing pretty much everything for you to keep the same electrical characteristics as you're welding down the joint. And the theory behind it is, on thinner material, even though it starts off and it's running pretty good, by the time that plate heats up, when you get halfway down the joint, the weld starts changing. So what this machine is supposed to do under power mode 40 is make those changes for you and cool things down and give you more wire where you need it, less wire where you need it, etc. The number that we have in this box is still related to arc length, but unlike trim, this one goes up to, I think, 14. Again, you're going to have to determine which one works best for you. Lower numbers are for thinner material. This is related to arc length again, but it's not quite the same as what the trim is. And I can still adjust my wire feed independently of my arc length. So play with power mode 40 when you're on that thinner stuff. And it'll take me back to the regular old spray arc. Okay, so I'm in spray arc mode here. I'm going to just estimate what I think my settings should be. I'm going to put 425 and we'll do 24 volts. So my machine settings under weld mode we've talked about. Now I'm going to start breaking down these other options. When I toggle down, my first setting I have is pre-flow, and right now I have this set at 0.2 seconds. So this is adjustable in 1/10 of a second increments, and I don't know what the maximum is. I like a short pre-flow, and what this does is when I push the trigger on the gun, it's going to have the solenoid in the machine is going to kick the gas on just 0.2 seconds before the actual wire starts to feed. The advantage to this is it blows the air out of your nozzle, so you don't get any contamination at the beginning of your weld because of residual air contamination inside the gun itself. I keep mine pretty low, 0.2 seconds at a 30 cubic feet flow rate is going to be plenty to clean out that nozzle. If you have it set too long, if I'm up there at 2.5 seconds or so, I'm going to pull the trigger, gas is going to flow, nothing's going to happen. My arc's not going to start, my wire is not going to feed. I'm going to think something's wrong with the machine, so I let off the trigger, reposition myself, I try it again, and just kind of repeat that process. I'm not waiting the 2.5 seconds for the wire to actually start. So I don't like it being too long. It gets me too confused, so I'm going to keep it down there at a unrecognizable 0.2 seconds. So pre-flow is before the arc starts. My next option is post-flow. This is what it sounds like. This is how long the gas stays flowing after I get done welding and I let off the trigger. This is something we use in TIG a lot, and this is to cool the crater of your weld, the end of your weld, in shielding gas. Hot metal oxidizes extremely rapidly. If I'm going to restart on that stop, it's going to be contaminated if I pull my gun away and there's no shielding gas to protect it. With MIG, it's a little bit different of a story, but where you are welding on 8-inch plates, you're usually finishing your weld at the end of a joint, so you're not really restarting a whole lot. If I did have a lot of restarts on a big long part that I'm working on, the post flow would be beneficial to cool that crater so that I can restart with a nice clean crater on it. The hardest part of that is when you get done welding, you actually have to stay there for that second so that the gas flows on it. And our instinct is to weld and then just pull away from it, and you're not getting the benefit of the post flow in that case. We'll keep that off for now. Our next option is what we call run-in, and this is very helpful, and I use this a lot, and whether you do or not is your business. Again, a lot of these settings are personal preference here, but right now it's off. So with the run-in, what's going to happen is I'm going to pull the trigger and the wire feed's going to be running at 426 inches per minute. When I'm welding on cold metal, just set up a new T-joint or a new butt joint, the wire has a tendency to sputter a little bit, and you saw that a good bit when you were in the hard wire MIG class. Pop, 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 right at the beginning of your weld. Most of that is the cold wire hitting the cold plate, and the puddle's not established yet, so it takes a little bit to get that heat build up. What the run-in allows you to do is set it, and again, this is a time frame, and I don't know what the maximum is again, but what this is going to do is allow the wire to come out a little bit slower at the beginning until it makes contact with the base metal, and then it'll ramp up to the preset or whatever your settings are for your wire feed speed. It keeps that wire from stubbing out, is the slang term for that. So right now it's off, and I'm going to pull the trigger, and there you see the wire just coming out at, again, 426 inches a minute. I'm going to turn it on, put it on 40, and again, this is time frames. I don't really know what that 40 means, whether it's 4/10 of a second or what. But you're going to see, let me bring the wire out a little bit. You see the end of the wire there? You're going to see it pull out real slow, and then it'll ramp up. Okay. So that is nice. I like that. You don't want the setting too high, or you'll get the same problem as your pre-flow. You're going to pull the trigger, nothing's going to happen. The wire's taking its time to get to the plate. You don't think there's been, you think there's something wrong with your machine, it's not working, so you let off the trigger, reposition, you try again, it's doing the same slow feeding for a while. So it is something you have to get used to, and I don't recommend too high of a setting on that. Our next one is our start, and right now I have it turned off, but the same problem that I mentioned before with aluminum, when you're starting off on a cold plate, the first ½ inch of your weld or so is not going to want to tie in, or maybe lack of fusion. May have lack of fusion on restarts because the metal has cooled down. So what the start allows me to do, and you see my numbers flashing, I can change these to a higher setting, and then for a period of time, in tenths of a second, I can have it run this amperage before it drops down to what the typical settings were that I determined were right for the joint I was welding. So I'd pull the trigger for 2.5 seconds, I'd be running this higher machine setting, and after that 2.5 seconds it's going to drop down to what my preset voltage and wire feed speed are. Again, that's nice for avoiding those cold restarts. For what you're doing in here, you usually only get that problem if you're starting a new plate, or if you went into the bathroom for too long and your plate cooled down too much. Start, need to play with that, see if you like it. Probably the most misunderstood feature on here is arc control. Arc control is fine-tuning at its best, and some people say they don't notice any difference, but I think they're crazy. Arc control does different things depending on what process I'm using. For spray arc and for hardwire MIG, flux core, when I go into the negative numbers, and I can go down to -10, I'm going to have a crisper arc. It's going to have a little bit more, a little bit less energy there at the arc, so the wire is going to tend to give me a little bit more spatter, but it's a little bit better for out of position welding, keeping the arc length a little tighter. When I go into the positive numbers, I have a little bit more increased energy at the arc. This usually cuts down on my spatter, gives me a softer appearance to it, maybe a little bit more fluid of a puddle. Again, that goes up to +10. You don't have to make major changes. I've never ran it at the full +10 or so, but I do recommend doing it in whole number increments and just notice what the changes are. So start at 0, run a bead, and just get a plate and run some pad welds. Start it with it off, run some pad welds, go up to +1, run a bead beside it, +2, run a bead beside it. Do that through the negative and the positive, and just notice what the difference is. You may like it, you may not, it's your business. When I'm in the pulse setting, what the arc control does is actually pretty neat, and it's needed sometimes. When I go into the negative numbers, again in pulse, I'm getting a peak current and a background, peak and a background, peak and a background. The machine is determining, when I have this off, how fast it should be oscillating between that high and that low setting. And again, this is usually happening, a couple hundred times a second usually. When I go into the negative numbers, it forces the machine to slow that pulse down. drive. When I'm slowing that pulse down, I'm limiting the heat input. I'm not in the high current range as often or for as long. When I go into the positive numbers, it's going to quicken that pulse up. So maybe if I'm out of position welding, I want it to be slower in the negative numbers. Maybe when I'm doing flat or horizontal and I can stand a little bit more heat to the puddle, I want a faster pulse. So I can change the pulse frequency. When I'm in pulse on pulse, it's going to do the same thing, but what it's actually doing is regulating how many high peak currents there are and the corresponding number of low peak background currents that there would be. Again, that's pulse on pulse. What that would do with pulse on pulse is whatever my given travel speed is down the joint, I could dictate how far apart I want those ripples. So if I go into the negative numbers, the ripples are going to be spaced farther apart, which would give it that stack of dimes look. If you speed it up, go into the positive numbers, the ripples will be tighter. At the same travel speed, they'd be tighter, or it would allow you to move quicker and have the pulse frequency you want. Maybe you got it set really hot and you're running really fast and the ripples are too far apart, so you can increase the speed of the pulse with the arc control. Very, very important feature. I use that a lot. In fact, that's fine-tuning at its best, like I said. You guys have 7 people running these machines. That arc control is what's going to give you a better weld than him if he doesn't know how to use it. Alright, our crater. As you guys have seen, if you've already been welding with the aluminum, when you get done welding you usually have a fairly large crater. What the crater allows you to do is, just like start, it allows me for a period of time after I let off the trigger, I can set a little bit lower of a current, so that when I let off the trigger it doesn't just immediately stop the arc and leave me that big crater. It'll stop the arc, it'll ramp down to a lower setting as it kind of fills that crater up. It's something you have to get used to, because when we're used to letting off the trigger, we pull the gun away. But we let off the trigger and we're actually still welding for however long I have it set for to fill that crater up. The burn back is set at an extremely small dimension right now, and these are dimensions instead of times. When you get done welding, what ends up happening is if you had no burn back at all, the wire would just weld into the end of the plate itself. So we actually have to have the wire burn back just a little bit to break contact with the weld. I can determine how far that wire burns back. Obviously, if it's set too high of a number, it's going to burn back into your tip and you're going to have all kinds of problems. It'll also leave you, the farther higher it's set, it'll leave you a larger ball on the end of that wire, and that larger ball on the end of your wire is more mass, so that's also why it tends to sputter a little bit when you start if you don't cut that ball off the end of it. So I can control my burn back length. The last setting here is spot welding, and this is not incredibly useful for what we're doing in here, but this would be if you were set up to do a lot of tacks or for a lot of intermittent welds where you're welding 2 inches here, 2 inches there. You can set this again for a time frame and your settings to where you pull the trigger and it'll weld for that length and let off. The machine will stop itself. It won't let you weld too far. You have to kind of time how long it takes you to weld 2 inches. Again, not real useful for the welding that we do here, but just a feature of that machine. So again, you've got a ton of options, a ton of controls on this machine. I highly recommend you getting that manual that I gave you. Go through it, play around a little bit, experiment, run some beads, try to see the difference between the different settings. Pick one out that you like. On your welding procedure, I have spray arc, pulse, pulse on pulse as options, along with the recommended or the required parameters that you keep that machine welding in.